Let's check out part B-1 of the June 2024 Chemistry Regents Exam. In this part of the exam, we have all multiple choice, 20 questions, a little bit more the math, a little bit more with the reference tables. Let's take a look. For 31, the numbers of protons, neutrons, and electrons in each of the 4 ions is shown in the table. Which ion has the greatest mass? With your subatomic particles, what you want to remember, it's your protons and your neutrons together that are found in the nucleus that give us the mass of an atom. Electrons have some mass, but it's so small compared to protons and neutrons, we ignore it. All you need to do is just add them up. You can see here that I added the protons plus the neutrons, put the numbers next to each of the choices, and sure enough, our biggest number is going to be choice 2. For question 32, the mass of a sample of nickel is determined to be 20.40 grams. How many significant figures are used to express this mass? Well, when you have any non-zeros in a measurement, it is considered significant. The only value that you have to question is a 0. Is the 0 part of the measurement, or is the 0 giving us the magnitude, how big or how small the number is? And I can tell you a simple rule: if you have any number greater than 1 and you have a decimal, you count them all. In this case, 20.40 means all of them are significant, which is choice 4. If you have a number less than 1, now it's a little bit different. For instance, what if the number was 0.0050? The numbers here in front are just giving us the size or the magnitude of the number. You move from left to right. You start with the first non-zero, which is the 5, and any digit, including zeros, to the right, and you count those as significant as well. In other words, for this measurement, we're talking 2 significant figures. Those first 3 zeros are placeholders. The other scenario, one more scenario, that's when you have a number greater than 1 and you do not have a decimal. For example, 2500. These 2 trailing zeros, as opposed to leading zeros, are placeholders. You don't see a decimal here. You're going to move from right to left, find the first non-zero again, and count any other digits to the left of that first number. And once again, the number of significant figures here is 2. If you need to review significant figures, check out my channel. I have a significant figures video. We're up to question 33, and lo and behold, this is the first tricky question so far from the exam, in my opinion. We're looking for the chemical name for the compound PbO2. You have to be careful with this, folks. It's very easy to say, oh, wait a minute, it's got to be lead 2 oxide because you see 2 oxygens in the formula. But you have to get more sophisticated than that. Again, I have a video on this on my YouTube channel. Lead is what's known as a transition metal. The Roman numeral indicates the charge on lead. Remember, your metals are your givers and your nonmetals are your takers. Okay? Now, for oxygen, if you go to the periodic table, you're going to see an oxidation number, which is also the charge for oxygen when it's bonding with a metal, of a -2. You look up lead's place on the periodic table and you see all different pluses, the +1, the +2, etc. Well, which one is this? Well, remember that this has to be neutral. It's a compound. The number of electrons that are gained by the nonmetal are lost by the metal. I have 2 oxygens, each gaining 2 for a total of -4, and that means that this lead atom lost 4. In other words, for 33, our answer is lead 4 oxide, which is choice 4. We move on from a not so easy question to a fairly straightforward question in 34, which formula is the empirical formula for ethane. As long as you know the definition of empirical formula, you are good to go. That is your lowest whole number ratio of the atoms in the compound. You got C2H6. I can divide both those numbers by 2, the lowest common denominator, or the highest common denominator, rather, and we get CH3. For question 35, we are given a balanced equation, including that it's exothermic because you see energy as a product. Which mass of O2 reacts completely with 5.6 grams of CO to produce 8.8 grams of CO2? Now, right away, what I always suggest is when you have numbers and a balanced equation to put the numbers on top of the equation. My CO is 5.6 and my CO2 is 8.8. Now, you might go ahead and say, oh, I got to go from grams to moles, mole ratio, go back out. Well, you don't even have to do that. You know that with chemical reactions, the mass I start with has to be equal to the mass I end with. I'm looking here for what the mass of X is, for oxygen rather. That's our X. So 5.6 plus whatever value for oxygen equals 8.8. So grab your trusty rusty calculator. 8.8 minus 5.6 gives us an answer of 3.2. For number 36, which numerical setup can be used to calculate the formula mass for this compound? When you're dealing with a formula mass, your units are U or AMU. When you're dealing with a gram formula mass, you would just put them in grams, but it's the same setup. I have to account for the mass of each of the atoms of the element, along with the number of times they appear in the formula. And if anything was in parentheses, I would have to go ahead and multiply or distribute within those parentheses. I don't have that here. I have 9 carbons, 11 hydrogens, 1 nitrogen, and 2 oxygens. You need to look up the masses on the periodic table, and you'll notice for the choices that they just went ahead and rounded. I have 9 carbon atoms, so my contribution there would be 9 times 12. For my hydrogens, the mass of 1 hydrogen is 1, but I got 11 of them. I have 1 nitrogen, and then I have my 2 oxygens. My answer is choice 4. For question 37, based on table F, which compound is most soluble in water? Reference table F is an interesting table. You either have a soluble compound or an insoluble compound. All we need to do is take these 4 choices and see which one is different than the others. Checking out reference table F. Now it says solubility guidelines for aqueous solutions. In other words, your salt solutions, your ionic compounds. You're going to have positive ions and negative ions, but when they are put in water, do they separate or do they stay together? If they separate, they are soluble in water, and if they do not separate, they're insoluble. Take calcium bromide, which is our first choice. The way this table works is you're not looking for the whole name of the compound. We're either looking for the calcium ions or the bromide ions. I know it's weird, but that's just the way that this table is set up. Just start literally from left to right. Do I see calcium? And my answer is no. I do not see, I see it here, but that's calcium with chromate. That's not calcium bromide. And I see it here with hydroxide. I go to bromide, Br minus. Start the same process. I'm going to start with the first column. Oh, here's Br minus. It is a soluble compound. However, there are exceptions, and those exceptions make compounds that are insoluble in water. Well, guess what? Calcium is not here. In other words, it is a soluble compound, calcium bromide. So I'm just going to write soluble on my test. Now I go to lead 2 sulfate. and I'm going to do exactly the same thing. I'm looking for Pb2 plus or SO4 2 minus. I'm starting from left to right. I don't see lead here. Oh, I see sulfate. Sulfate compounds are soluble. However, there are exceptions. And notice one of the exceptions is lead. That makes lead 2 sulfate insoluble. All right, that's interesting. Let's go to silver carbonate. I start from left to right. I don't see silver here. I don't see carbonate. I see hydrogen carbonate, but that's different. All right, none of the exceptions. I bounce over to the third column, and here is carbonate. Carbonate typically forms insoluble compounds, and silver, Ag plus, is not group 1, and it's certainly not ammonium. It means it's insoluble. And finally, for the tin 2 hydroxide, tin's symbol is SN. I don't see that anywhere here. In fact, I don't see any hydroxide, but sure enough, I see it here. Hydroxide compounds are typically, again, insoluble, except for these different ions, which SN is not part of. Once again, I have an insoluble compound. In other words, for question set 37, based on table F, the only soluble compound is calcium bromide, and that's our answer. For 38, we're going back to the tables. We're going to table G. Which combination of solute and solvent will form a saturated solution when thoroughly mixed at 20 degrees Celsius? Oh, this is really annoying. Now, saturated means that you've maxed out the amount of solute. In this case, these are the solutes in a given amount of solvent, which is water, 100 grams of water, right, at a specific temperature. So we're going to have to go ahead and find these points on our graph and answer our question. We are at reference table G, and we're going to look at the points, as I mentioned, on the graph. We have 20 degrees as our temperature, so I'm going to go ahead and draw a line for that. And then we can go ahead and kind of mark up the graph. When you're taking the exam, by all means, mark up the reference tables. They're yours to use. Leave them a mess. That's all I got to say. All right, 15 grams of KClO3. They're all in 100 grams of water. That is important because if the amount of water changed, so would the amount of solute that would dissolve in a certain amount of water. 15 grams. I'm going to go ahead and go across and just make a little X at 15 grams. Now, KClO3, we're going to go down. The line means you have a saturated solution. So anything above the line, if it's at a specific temperature, it means that you have excess sitting at the bottom of the container. So choice A is our answer. We shouldn't see any that are above the line or on the line for the other three choices, but let's check. The next one is 20 grams of KCl. 20 is right above the 15. KCl, if I follow the line, that point is below unsaturated. NaCl, 30 grams. 30 is right here. NaCl is this line. It's below unsaturated. And for Ki, we're talking 35 grams, just above. But Ki is way up here. In fact, out of the view, essentially, of the screen, that is way below the saturation line. So again, it's the KClO3, which is choice 1. I think I said A, but you get the point. It's the first choice. Moving on to 39, solution that has a mass of 2,000 grams in, okay, that's the solution, and it contains 0.050 grams of dissolved solute. What is the concentration in parts per million? On reference table T, you're going to have your parts per million equation. The key I'm going to show you right now, and what I would suggest with any type of math that you're doing for this test, write the equation down, whether it's a scrap paper or not. And we got the mass of our solute over the mass of the solution times a million. Now, I'm just showing you this. A lot of times kids want to do stuff in their calculator. I'm not a big fan. I'd rather you have it on paper first. You don't want to make mistakes. The key is you're asked about the mass of the solution, and that is given as the 2,000 grams. That's going to be in our denominator. The mass of the solute is 0.05 grams. If you were given the mass of the solute instead of the mass of solution, the mass of the solvent instead of the mass of the solution, you would have had to add the solute and the solvent together. In this question, they gave you the mass of solution. You didn't have to do that. 0.05 divided by 2,000 times a million. And use your trusty, rusty calculator. When you do this, of course, I'm going to do that myself. I get an answer of 25 grams, which is hard to see because of my writing here, but is choice 2. 10 down, 10 to go. Question 40. A person with a body temperature of 37 degrees Celsius holds a cup of hot water in their hand. The temperature of the cup is 44, air temperature 22. Which phrase describes a heat transfer that occurs in the system? Heat is always going from hot to cold. I wouldn't even look at these answers until I went ahead and kind of processed the information. The highest temperature is the cup. The cup is 44. Then it's the hand, which is 37, and then the air, which is 22. Okay, now obviously your hand is surrounding the cup. So it's going from the cup into your hand and the air, right, where your hand isn't touching, and then your hand to the air. Let's see what our choices say. Air to cup. Can't be that. Let's get rid of that. From the hand to the cup. Again, we're going up. From the air to the hand. Nope. But from the cup to the hand, and that is our answer. Choice 4. On to 41. What is the amount of heat absorbed to completely melt 26.2 grams of water as a solid at 0 degrees Celsius? We are just dealing with one of the heat equations here. I'm going to show you which one and why, and then we'll come on back. Good old reference table T. I do want to point out on that last question, we were calculating parts per million. I didn't go to the table and show it to you because it's play the matching game, right? It's right in front of you. However, for the heat equations, there are 3 different heat equations. So we do want to be careful there. They're all with heat or Q. So what gives? Which one is which? Well, the Q is equal to MC delta T. You're going to have a phase change. You're going to have a substance at one phase rather, and you're going to have a temperature change. That's where the delta T comes in. That is not the case. We were melting ice, which means we have a phase change. Anytime you have a phase change, temperature remains steady. And that is why you see with these other 2 equations, there is no delta T. Heat of fusion, I know it's weird, but means melting. Vaporization, right, is when we're going from a liquid to a gas. And of course, these can go either way. So heat of fusion, solid to liquid. You could go back the other way, liquid to solid. Heat of vaporization, liquid to a gas. But a gas could condense back to a liquid. We need Q is equal to mH sub F. Now, the heat of fusion is a constant, just like specific heat capacity, just like heat of vaporization. That is on the front of the reference table. Here we are, table B. I need the heat of fusion. What this means is for every gram of ice, 334 joules of energy are required. Here is the equation. I plug the values in. Remember, there is no delta T here. And you might say to yourself, well, wait a minute, hold on. There is a temperature. Well, of course, things freeze and melt at 0 degrees Celsius, just like we have boiling and condensation going on at 100 degrees Celsius. But it stays constant. It's no delta T. It's a constant temperature. It doesn't belong in the equation. And now what you're going to do is 26.2 times 334, and you get an answer of 8,750. And you go, great, it's not here in the choices. Well, what they did was they put it into scientific notation. That's all they did. Hopefully you know how to use your calculator and you can go ahead and change it into scientific notation. The obvious answer anyway is going to be choice 1 because you see the 8.75. Literally all we're doing is sliding the decimal over 3 spaces, and when we make the number in front smaller, that means we have, of course, a positive exponent, and our answer is choice 1. For 42, we're dealing with a cooling curve, and it says that it's beginning in the liquid phase. I always recommend that you mark up the cooling or the heating curve before you go to the questions. So we started with the liquid phase. Then we went from a liquid to a gas, and then just a gas. Let's take a look at the questions. Which statement describes the average kinetic energy and the potential energy between minute 2 and minute 6? You got to remember, average kinetic energy is a way of saying temperature. And since it's a horizontal line, that means our average kinetic energy is staying constant. Oh. With question 42, we have a cooling curve graph. We only really have half of the graph. We're starting with the liquid phase. I always tell my students, let's mark up the graph. Temperature is going down, so we're going from a liquid to a solid. And in the question, it says, which statement describes the average kinetic energy and the potential energy between minute 2 and minute 6? Well, average kinetic energy is another way of saying temperature. I have a horizontal line here. That means that the temperature is remaining constant. However, my potential energy is decreasing. Why? Because all of the particles, whether they're atoms or molecules, they are coming together. There's less potential for reacting with another substance. And with that information, let's take a look at the choices. Average kinetic energy and potential energy both decrease. That's not true. Average kinetic energy and potential energy remain. That's not true. Average kinetic energy remains constant. Potential energy increases. That's not right. It's actually decreasing because it's going to a solid, which is choice 4. Checking out question 43. Which formula represents a saturated hydrocarbon? Saturated means all single bonds between the carbons, and we're dealing with carbons bonding with hydrogen. Our answer, therefore, is choice 1. We're dealing with alkanes. If you're not sure, you could go to the reference table and check out an alkane versus an alkene and an alkyne. They're all hydrocarbon. In other words, just hydrogen and carbon, right? So choice 3 and 4 is not going to work because it's a saturated hydrocarbon. For question 44, given the equation representing a reaction, which type of organic reaction do we have? Just look at the reactants versus the products. I have an alkane and a halogen, right? So this is BR on the left. Now, the bond here is broken and the bond here is broken. And what do I end up with? I end up with a bromine on my hydrocarbon and hydrogen bromide. In other words, there's a switch. A bromine takes the place of a hydrogen, which is substitution. For 45, in which compound does sulfur have an oxidation state of +4? In order to figure out sulfur's oxidation state, we have to look at the other atoms around it. In case you didn't know or forgot, oxidation states are on the periodic table. They're in the upper right-hand corner. For sulfur, we see that there are 3 different ones. That means that sulfur is either gaining or losing electrons depending on what it's bonded with. We need to use the oxidation states of the other elements as clues to figure out sulfur's oxidation state. And when we say oxidation state, what we're talking about is what's going on with those particular elements' atoms when it comes to bonding. Now, in choice 1, we have potassium. When you look up potassium's oxidation state, it only has one, and it is +1. And you have two potassiums, total up +2. That means sulfur in this case was a -2. Now, when you have a metal and nonmetal bonding anyway, your metals are your givers and your nonmetals are your takers. And everything, remember, for a compound has to add up to 0 because compounds are electrically neutral. In choice 2, calcium, if you were to look up the oxidation state on the periodic table, is a +2. And I have one of those, and I have one sulfur, which is a -2. That's why it's a 1-to-1 ratio. It's an even exchange. Now, for choices 3 and 4, it's going to be dependent on the number of oxygens. You look up oxygen's oxidation state, and it's a -2. Well, for SO2, you have 2 oxygens. 2 times a -2 is a total of -4. That means the sulfur has to be giving 4 electrons per atom, or the +4. And that is our answer, choice 3. Let's check out, though, choice 4. For SO3, again, each oxygen atom is gaining 2 electrons, but 3 times a -2 is a -6. It needs a total of 6. That would make, for choice 4, sulfur +6. That's not what we were looking for. Again, the answer is choice 3. 46, which solution is the best conductor of electricity? When we have soluble salts, ionic compounds in water, we have electrical conduction. The only other way we have electricity or electrical conduction, it would be with metals. Now, when a salt breaks apart, it breaks apart into ions. It turns out that all of these solutes are exactly the same. Calcium chloride, for every calcium chloride, you're going to get 3 ions, a calcium ion and 2 chloride ions. And you just look at the formula to figure that out. In this case, then, our choices are all just based on concentration, and the highest concentration is your 1.0 molar, which is choice 4. So remember, with solutions, it's got to be a soluble salt, then it depends on how many ions it breaks up into, and then the concentration also. For 47, given the incomplete equation representing a neutralization reaction, what is the formula of the missing product? You can always go ahead and just list everything, right? We know it's a balanced equation because we do have the coefficients of 2 in front on both sides. This is neutralization. I have a base, which is the strontium hydroxide, and an acid, nitric acid, forming a salt and water. But if you don't realize that what happens is it's really a double replacement reaction. You got your strontium and you got your nitrate, and now you're going to go ahead on the other side. That's going to form your salt. Now, I'm doing a lot of nows here, but the problem is strontium. Strontium is in group 2. It's +2. Nitrate is on the polyatomic ion table, which is a -1. Strontium nitrate is going to be SrNO3 2, which is choice 4. The other way you can do it is just do an atom inventory. Let me show you what I mean. Literally, all I did was draw a line to break up my reactants and products. I have 1 strontium on the left, 8 oxygens, 4 hydrogens, 2 nitrogens. And on the right now, the 2 H2O represents 4 hydrogens and 2 oxygens. What am I missing? I'll just put it in a different color, right? I'm missing my strontium. I'm missing my 2 nitrogens and 8 minus 2, 6 oxygens, which of course this is a polyatomic, which is choice 4. For question 48, given the reaction representing a reversible, given the equation representing a reversible reaction, the water molecule acts as an acid because it. Well, there's 2 definitions for an acid. Arrhenius's definition is that an acid gives us H plus as an ion in water. The other definition, which New York State calls the alternative definition, or the other acid-base theory, is that water is what they call a proton donor. But a proton really means an H plus donor. Now, that's exactly what we're dealing with here. We have ammonia, NH3, becoming NH4 plus. At the same time, H2O is becoming OH minus. What does that mean? That means that the water molecule donated an H plus from the molecule to the NH3. And how do I know that? Because I have my before and I have my after. And the answer here, since it's donating hydrogen ions, is choice 3. Be very careful. Do not get the word hydrogen ion, which means H plus, confused with hydroxide, which is OH minus, and confused with the hydronium ion, which is H3O plus, right? Which is water with H plus. They sound alike, they look alike, but they are different. For 49, which nuclear equation represents beta decay? Well, first of all, to have alpha or beta decay, you're starting with 1 radioactive isotope and it's breaking apart. Therefore, it cannot be choice 3. And it can't be choice 1. So, in other words, what I'm trying to say is you're starting with 1 reactant. Now, the question is, what is the particle that's being shot out of the nucleus? In choice 2, it's a neutron, but in choice 4, there it is. That's the beta particle, and there is our answer. There is a reference table that lists the particles and their symbols. Let me just show you that quick. Reference table O gives you names, gives you the notation or the kind of the symbols with the numbers and then the symbols themselves. There is our beta particle, and we saw that in the question. Drum roll, please. We are up to question 50. We got equations A and B. They are both nuclear equations. The dead giveaway is always when they give you mass numbers and atomic numbers with the equation. And it says, which type of nuclear reaction do these equations represent? Before you even look at the choices, you have to be able to recognize not only the alpha and beta decays, right? Gamma radiation, and then also fission, fusion, and transmutation, whether it's natural or artificial. That was a lot to say. But fission and fusion are very easy to distinguish between. Fusion with nuclear means coming together, taking light nuclei like hydrogens, heliums, lithiums, for example, bringing them together. And fission, that is the reaction that we use for nuclear energy. So that's fairly easy to recognize because you're dealing with uranium. And sure enough, equation B is our fission, and equation A is our fusion. Getting back to part A of the test. And you also see it here. A lot of the questions are vocabulary driven and being able to recognize symbols. And of course, using the tables and a little bit of math, it's everything. But my point is, you've got to know certain vocabulary words very well. With that information now, let's answer the question, and that is A is fusion and B is fission. This ends part B-1. You've gone through now all the multiple choice. We're on to now the short answer questions. A lot of times students will make the mistake and not practice short answer questions enough. Don't be that student. Make sure you look at all the different types of questions for the test. I wish you well and good luck.